I'm going to get out of here.
Tim, are you going to keep that up for me?
Looks like Tim went away.
Okay.
Hello there. Anybody there?
Hi, good afternoon.
Hello, good afternoon. Good morning to me. I'm in California.
Welcome.
So who's this?
So this is Alicia Moniz. Hi, welcome. And we will be joined with Matt Gordon and his session Dialogue with Your Data, Interactive AI with Azure Cognitive Services. And we will probably be starting at the top of the hour.
Azure Garden. I thought that would be my session now. My name is Armando. I'm scheduled for noon at AI ML embedded in Azure Data Platform.
Oh, I'm early then. Hi, Armando. Yes, that is your session. Hi, Armando. This is Alicia Moniz. How are you?
Okay, I got scared now. Did I miss my session? Time zone things or something?
No, I'm early. You're on time.
All right. Yeah, sometimes I mess up this time zone thing.
You know what it is I am on Central Time. So yes, I do that all the time. So I think you do have a proctor. Hey, Matt.
Yeah, hopefully my camera will catch up. I need to buy a new camera. It starts dark and then gets better.
Well, good luck finding a camera for sale out there. Definitely not going to find anything at the Best Buy. I've tried.
It's hard to find a Best Buy.
Yeah.
Some of them are closed.
So Armando, I didn't think you were gonna show because you didn't respond to the email. So I'll let you do the presentation.
Oh, you thought I wasn't? I was supposed to answer something?
Yeah, I didn't get a confirmation from you, but that's okay.
I mean, you want to switch my slot? I can present
No.
later, no problem.
No problem. It's all yours. It's all yours. I had a backup slide just ready to go, just in case.
I was in the prep session 2 days ago.
Okay. Very good then. My mistake.
I think what Matt means is most likely, Armando, you may not have accepted the invitation on Session Eyes. You know,
Yeah.
once the session is selected, you get an email where you have to confirm participation, and sometimes those emails go to junk or a different folder. So that may have happened.
Sorry about that. I may have
No
missed
worries.
it.
No worries. Glad you're here. So
I'm glad to be here. Thanks for having me.
no problem.
All right, I'm gonna go grab some water. Be right back.
Okay. And Matt, are you going to be like available for this session to proctor, like start and stop the recording?
Yeah, I can do it.
Okay, thank you. That will be perfect.
Yeah, so Matt, I'm actually a session early. This is Alicia again.
Mhm.
So if you want, I can hang out and do Q&A. But if you did have a proctor for this slot, then I can come back in an hour.
It's up to you. I can proctor.
Okay. I'm gonna hang out then as a spectator.
Okay.
Thank you.
So I got my water here. We know that Guinness is now white. So we'll be virtualizing it in my head. All right, so where's my PowerPoint? And present. Should I share my screen?
Yeah, you can go ahead and share your screen. And I'll start the recording. Or this recording has already been started, so I think we're good to go.
Cool. I'm still looking for I think this is my screen. Yeah, this one. Yeah, so this is session nice. And I don't know. We'll figure that out later. So we good to go, right?
We are good to go.
Okay, so I think to get that feeling that we are officially starting, my official good morning, good evening, and good afternoon to everybody in the audience. Happy to have you here around, guys. My name is Armando Lacerda. I am a data specialist. I'm certified in data engineering, data architecting. I've been working with data for the past 20 years plus. A developer at heart. I started as a developer, and now I've been focusing my career around the data platform, specifically in Azure. And I've not been playing much with AWS, with Amazon Web Service. I'm also a Microsoft MVP and a Microsoft MCT. MVP is an award. I just got renewed yesterday. They do this once a year, and I got lucky enough to be recognized by Microsoft by my contributions to the community, like this one here. When you come and present for free, you got the honor to be here with at this event. So that's the MVP thing. And the MCT is Microsoft Certified Trainer. I've been teaching official Microsoft classes for about 25 years on multiple subjects. And this is one of the passions that I have, to share knowledge. And the classroom, that it's kind of a it's kind of a well-known say that the teacher or the trainer is the one that learns the most in the classroom. And that's why I love to be in the classroom, because every new class I get to teach, I not just share what I know, but I learn a lot and how to apply my skills to the students in the classroom. So it's something I just have a passion to do. Currently, I'm working on a multi-petabyte database migration project from on-premise to the cloud. And we are using a lot of AI and ML in that project. And in this consulting career of mine, as we go to clients and we start talking about how AI and ML can help their particular cases, their particular user cases, I find myself explaining, how those things work and how they can be applied. And that's how I came up with this particular session. I put this collection of slides together. I actually mixed up with a few other slides I got from Microsoft Ignite. And that's what I'm here for, right? This is pretty much a summary of a bunch of consulting presentations I have done at clients. And I hope it's beneficial to you. On this slide here, just to highlight it, this link here is where you can find the original slide deck. It's not this particular slide deck. I will be uploading this slide deck here later to the events platform. You guys have a link to download presentations from there. I'm going to upload this one there right after this session. But that link over there, aka.ms.aiml300, is where Microsoft has made a session they have presented at Ignite last year in November down in Orlando, when we could still have live in-person events. And there are some hands-on exercises there if you guys are interested to take a look on that one later. All right. I got the first 6 or 7 slides from that presentation here, so I decided to keep the references for credit. Right. It's this first portion is from that slide deck, which is available to the public. I'm about to conclude my a extension class at MIT on AI and machine learning. Actually, the class is from data to decision, AI and machine learning. It's an extension class. It doesn't give you credits, but MIT is always good to have good contacts. And one of the things I have found out during this consulting projects and when presenting on this and taking this class with MIT as well is it's a great machine learning and how it applies and how the companies out there like Microsoft and a few others, they are implementing machine learning and AI as a whole. The terminology becomes a little blurred, a little confusing from time to time. When I started my class 7 weeks ago, I had a little hard time trying, matching up my vocabulary with the people in the classroom and the trainers and the facilitators. So I decided to add up in here a few concepts that are important if you are somewhat new to the machine learning aspect at the Azure platform. There are some important concepts you have to keep in mind so you can actually apply either the machine learning or the AI service, the cognitive services in Azure to the particular endpoints where the data platform supports and other services in Azure also supports. So let's go over here just quick on some of these concepts, the most important ones. The first of all is the concept of artificial intelligence. So artificial intelligence is not a service you're gonna find anywhere, right? Artificial intelligence is pretty much a concept, an idea, a goal of trying to mimic human intelligence. And you can implement that in multiple ways, but the overall goal is that, how do we think, how do we apply cognitive skills to a particular subject. For instance, I remember like 25 years ago, 30 years ago, when I was still in college, people talking about how the human brain identify objects, identify things, and how the objects are broken down into small portions or small geometric objects. And I remember some studies of even on a monkey, how monkey gets confused with bananas and some other elements if they just shape the same, and then creating the algorithms to identify those particular shapes. So that's the idea. The idea of AI is to understand how our brains work on a particular subject area, and then try to implement algorithms that will do the same, that will implement the same behavior. Now, like I said, there are multiple ways to accomplish this. Really narrowing down, laser focusing on Azure, what we see there is we can go two paths. We can go down in two roads when we go, when you start implementing AI in the cloud in Azure. One path, one specific path is when I'm gonna work on a subject area for my business where there is no pre-developed models or pre-developed statistic models or algorithms to the subject I'm going to work with. For instance, these are well-known cases that Microsoft has published in their website. So for instance, there is this one I like a lot. There is this salmon farm up in North Europe. And they have these farms like they have this fence underwater, and they have the salmon there in this fence, and they grow the salmon, keep feeding them until they get to a point where they can be harvested and then sent out for sale, right, for industrialization and sale. So the whole goal in there is like when the salmon's big enough, has age enough to be harvested. So the idea here is that one on image recognition, but for a subject that there was no image collection predefined. They had to work with particular edge cases in there, and one of them they mention about is like when two salmons go side by side, and the machine learning thinks the camera thinks just one big fish, and they have to break that down, some specifics in there. The bottom line is when you work in a case that nobody else has worked before, I mean, the subject may be on a same field like image recognition. A lot of people do image recognition, but in your particular case, you're not doing like let's say product recognition. So if someone puts a laptop on the table, or if someone puts a glass on the table or a keyboard on the table, these are industry already resolved algorithms. So we can use something that's already created, is already there, it would save you time. But again, to the point I was making before, when you are in image recognition, trying to find specific characteristics that are to your business that nobody has developed yet, so you have to rely on machine learning solutions. And the machine learning solutions in here is when you go into Azure Machine Learning Studio and you start collecting your data, working your features or columns in a table. So you start working with your features and understanding your features, and start mapping your features to what they represent. So when you go into machine learning, you are really starting from scratch. There are predefined algorithms that you have to train on your data set. So those algorithms will generate results that are specific to your business case. So the first point in here, in summary, is if I'm going to apply artificial intelligence somewhere in my architecture in the cloud space, particularly in Azure, I have to understand if my AI case is something that I can find somewhat resolved in the market or not. If it's the second, if it's the latter, I have to develop for myself, I go into Azure Machine Learning. And in that case, where is my browser? Browser. Here's my browser. So in that case, what you do is you go portal.azure.com, and let me maximize this so we don't get confused with this light in the middle. And let me get this larger. And someone already told me that for presentations, it would be better if I get it white bright. So let me get it white bright. And close this and close this. Yeah. And so I would come in here and say, you know what? I want to create a machine learning. There we go. So I can get here into the machine learning service. I can create a new workspace for me. That's my workspace details. So here in Azure is this simple, right? I just have to come in here, pick up, we still have a resource. Let me use this one. So I pick a resource group in here, make it a name. So this summer 2020 Azure Fest. And let's get a data center that's closer to me and full featured. It seems like this simple, right? And it really is. Just to get started, it is this simple. You're gonna get your workspace created once validated here and created. And once this is done, if you have any experience with Azure and Azure data services, you more likely have seen Azure Data Factory. When you create the data factory in Azure, you have another portal to deal with the data factory itself, with the pipelines and transformations, all of that. It's going to be the same case here. Once I've created my workspace, there will be a button in there where I'm going to click on that button and I will get a workspace. We're going to go back to that workspace in a second here. In that workspace is where I'm going to create my entire experiment to train a model, a statistical model that already exists. I'm going to select one. I'm going to train a model and get that model ready to work on my business case. So while it's doing that, I'm going to go back in here and switch to the second one. So yeah, that's the first one, machine learning. The second one, and my mouse is here, perfect. The second one is when there is a variant of the machine learning, which is the deep learning aspect of it. And the deep learning is really more specialized algorithms when you go into neural networks. And the idea of the neural networks in there, it's worked with more complex object recognition. For most of the time, there are some other pattern recognition that can be used with neural networks too. And to work with neural networks, you can get started with in the machine learning itself, but there are some other aspects and environments where it would be better applied. The other one that is, I thought I had it in this slide, but it's not there. But the other one that is in there is when the case is already created for you. There is well-known algorithms for those. For instance, let's say you want to do, you want to classify the mood of your business image in the social media. So you want to learn if people are talking good or bad about a particular topic or about your business. So getting sentiment analysis on text, it's something that's being mapped already. This is the kind of thing you don't have to develop on by yourself. So for those kinds of cases like this one, when there are predefined solutions and you just have to parameterize or do little adaptation to your case, where you go into the cognitive services in Azure. So, and let's go back here to the portal to show that to you. This is still processing. So let me get another tab in here. Portal.azure.com. So let's get back there to the portal. And let's create a resource. And let's go for cognitive services. Yeah, this is not real dollars. These are just credits that Microsoft gives to us as trainers and as MVPs to do this kind of presentation, so we can show you stuff. and this is it, right? So the cognitive services is the ones where the models, they are already trained to a bunch of business areas or common areas that are used by many business to apply machine learning, right? To get machine learning created. The bottom line here is when you create a cognitive service endpoint for you, Microsoft is backing it with all those API, I mean, all those models that are being already trained on a bunch of subjects like text recognition, image recognition, speech recognition, widely used for automated customer service through bots. It's a very common application we find here. There are over 30 services in Azure Cognitive Service that you can use in all of those 5 or 6 areas, image recognition, text recognition, and a few others. So see search, speech, Azure Vision, language. So I'm going to go ahead and create one here. And this one here is the easiest one to use because you don't have much to train the algorithms on. I mean, when you get to the Vision one, you definitely have to upload your images for matching. So it has to learn about your objects when you work with that. But for text, for instance, for text recognition and sentiment analysis and all of that, these are pretty much all trained. So it's, in 10, 15 minutes, you're good to go. We are flying, implementing your applications or backing your applications with this service. So let's do it here again. Summer 2020 Azure Data Fast. And let's get it closer. Oh, yeah, sure. Not this one. Better? Nope. And here, let's get it close to me. Price tier, a resource group. SQLA, the one I did before, and go for it. So once this one here is created, deployed into my subscription, what is gonna happen here is I will be getting a endpoint, a collection of API endpoints. And as a developer, I don't have to develop the models anymore. They're already there. I just have to consume the models. So why this one is great, I'm going to go back to my presentation, to my slide deck. And we'll go back to this one in a bit to see how we deploy it. So that it's so far. Just to make a very important comparison here when you do machine learning and AI, is that regardless how you do it, if you do from scratch or if you do it from the cognitive service, which the models are already there, and you have you shorten your time to market a lot because you just have to train with particular data. The model is kind of ready to go, good to be consumed. In either case, regardless of which way you do, you have to understand this difference in between implementing regular business computing approach to machine learning approach. So the traditional business goes like you get data, you program your code, you run these two together, and you have your output. We know that, right? Input, process, output. When we are in machine learning, this process is twisted a little bit. Because when you do machine learning, what you actually get is data in the standard data and training set data and verification data. And once your computation model gets to a point that your training set has trained the model to predict what it should be with your task comparison results, what you get here is a model. And the model is actually what goes out into production. So notice that you have data in and what you expect to get out as an input. So you make sure your models, they are accurate enough, right? And accuracy is like percentage grades. So it's funny because we feel like if I train a model good enough, I'm going to have 100% accuracy, right, on my predictions. Like the data that comes in when comparing to the outputs that I'm expecting, they will match 100%. And that's how people think. It will be our first, our first inclination to that. But it's actually counterintuitive what really happens is if you get a computation model that gets 100% on your training set, it means it's biased. You really, it's overtrained. And when you get real data, not your training data, more likely you're going to have worse results than if it was not that close to your expected training results. So it's something that's kind of counterintuitive. A lot of people, I get customers that are like, this model is not good. It's like 99.95% accurate. Of course, there are more digits in there, but they look at that, they say it's not accurate enough. I say, that's great. If you get 99.95% in real data, like we are getting training, you're really good. If you get 100%, experience shows that on the real data, you get worse predictions. But in any case, you get the data in, and what comes out in here is not data, because we're already comparing the data. What comes out is a trained model. So your algorithms is actually your model. And it is this model that you're going to deploy everywhere in Azure. Not just not everywhere, but in places where you can deploy your trained model to process the income data that will come in production. And that's the beauty of AI, right? Get this algorithm here, get this model in any place where data can be processed. And there are, as we move along here, this is where exactly we'll see. This is exactly what we'll see where we can deploy these models. So when should we use machine learning? It all depends on the case, right? You can use regression, classification, clustering. These are all kinds of algorithms or statistical models we can use to get a data and try to predict what that data means, right? Where to my business or to my use case in particular. I got another slide here that will tell us some of the options we have in the machine learning modeling, machine learning workbench, where we can model these things. So here we have supervised model and unsupervised model. Means that if I am to tell the algorithm how it's supposed to, what the parameters are supposed to look for and cluster things together, regression and classification are great for that. But unsupervised is when I have no idea what the data looks like when it's coming in, and I want the model to analyze the data and figure out the clusterings by itself. How they get close together to itself, or when they are off of what would be the normal curve or the normal cluster. An interesting case, it was my first one 6 years ago when I first started doing this. It was having 2 microphones, and we want to have people talking to these microphones, and we want to filter the audio data coming in to the microphone that had someone speaking to. And that was an application of unsupervised data, because we didn't have the voice patterns of anybody. We didn't have any data or features to pre-train the model. We have to analyze the data as the data came in. And so that was an interesting application, still in my mind, because it was the first one I implemented as a lab when I first started working with machine learning. By the way, this algorithm is public. A bunch of people have implemented it besides me, and you can Google it. You're gonna find that algorithm. It's pretty interesting to see it working. In any case, this is the other slide I mentioned about the types of algorithms you're gonna find in Azure Machine Learning Studio. And you're gonna have this on my slide deck. It's also from this slide deck here, like I mentioned earlier. And that's a good guidance to you, right? What you want to do. You want to predict values. You want to extract information from text. So these are algorithms you will find in Machine Learning Studio, not in the Cognitive Service, but in Machine Learning Studio, that you can have your text through and customize the text recognition to your particular case, because the ones in Cognitive Service are not helping you, or they're not fine-tuned enough to your case. So you're going to create a model of yours and deploy it where you need your model, right? So the bottom line here so far is, if I want to leverage AI into my Azure solutions, I can choose from develop my models or use pre-trained models that I would definitely going to tune them up, customize them a little, but pre-trained models, and then call either one or deploy my machine learning one that I have developed to particular places where machine learning needs to be applied, right? So the second half of this presentation is where you're going to apply those things. The first half is to understand what are your options to get machine learning implemented and how to get it ready to address your business case. Yeah, so to finish up this first half, when is machine learning the right tool? When I want to forecast or predict, or when I want to optimize or be proactive, like in terms of security and credit assessments and things like that. So with that in mind, do we have any questions? So quiet here. Let me take a look in the chat window if there is any activity in there. All right, whoops, it's clicking here. And where is my, oh, there we are. Let me take this aside, put in here. I don't see any questions. If you have any questions, yeah, no, just the teaser, just the color. So apparently no questions. All right. Either I'm so boring that everybody fell asleep already, or I'm doing a good job in presenting it well. Let's move on and see what's next. Yeah, so on the next three slides, what I'm gonna present here to you is some of the Azure reference architecture that you can find in the Azure website and where machine learning can be applied. And the last one will be the one where you're gonna take a look particularly on the data platform and Azure Synapse and some other opportunities in the data platform there. So the first one, when we operate in the cloud, most of the time we have everything you want to compute at the cloud, right? Everything you want to have processed, we want to leverage cloud computing. So it's the scale, it's on demand, it's all those benefits in the cloud. But especially with IoT scenarios, IoT scenarios, we there is the need to process machine learning models, the way they call it, at the edge, right? So we call it the edge because, like the name implies, we for whatever reason we don't want to send that computing to the cloud, and the most common way, I mean, the most common scenario about that approach of deploying your machine learning algorithm is, when you, for instance, when you do image recognition, and specifically when it's about security or threat detection. For instance, imagine that you have a camera, facing the perimeter of your building, and there is an intruder detection. If that image has to travel up to the cloud and being processed in the clouds, and then the intruder is detected and a trigger has to be sent back, the round trip to the cloud and back that can take to the cloud and process and back that can take over a second can be too late. The response time can be too late. Like if it's a fire danger, or if it's a automation device, automation robot that's malfunctioning, that lagging going to the cloud and back can be, what defines life and death. So what you see in this kind of scenarios is getting your machine learning model developed in the cloud. So we go into Machine Learning Studio, which is here, should be here. Okay, so this deployment is done, and this deployment is done. They're both done. So let me get to this one first. And for whatever reason doesn't want to go to the resource. Let's try this. Perfect. Yeah, so you would go in here into your machine learning environment, and you're gonna go into the machine learning studio. And in the machine learning studio, do all this process I have just explained to you, right? You're gonna get here into the workbench. Let's get my account again, and starting creating your experiments. Come on, you can do it. Don't ask me again. All right, that is this one here, I think. And that was this one. No one here, no one here. Oh, I'm sorry, I just got lost in my subscriptions. No machine learning on this one, so it was this one. Try it again. All right, close this, launch it again. Oh, there we are. Now went through. So welcome to Machine Learning Studio. Let's close this wizard in here. And here we are. We got support for the notebooks. We can do our experiments in here and start bringing our elements. And we need compute support for our elements. We can try to do it by AutoML or pipeline or by notebooks. So we can run our experiments in here. And I'm looking at my clock in here to make sure it's still on time. Close this. Can you please zoom in? Yes, sure. Sorry about that. Forgot about it. Better? That was this one. Of course, no problem. Patel, yeah, no problem. So yeah, so that's where you go for your experiments and bringing your data for developing your model. That's where you create your model. So everything you're doing here, it's like the name says, you know, it's a laboratory, right? It's your experiment, it's your exercise. You are preparing something to get into production. And an important concept in this new approach for the workbench is that you define your compute power for your experiments. And this is where the money comes from, right? You pay actually for computing. It's pretty much what you do from here. So what you do here is not production, is, like I said, is development, is that portion when you get your features and your labels and you apply to models in your workbench. And once you get a model that is good enough, you know, that you get accuracy to the point you feel confident it can go into production, deploy to the edge like we're talking, is when you're going to export it from here. And here it's your endpoints for consumption when you have it there. We have to do the whole mapping here. If you have time, I'll go back here in a second. So the bottom line here to get on track on what we're talking about, we are reviewing this. So I want to have my model, my image recognition, my elements working at the edge. And notice that the name, when they mention the edge, it's actually, it feels like on-premise because it's outside Azure, right? It's running at the edge, at the endpoint. But it would be running not on standard computing elements like you would run your Windows server or your Linux server on-premise, but it would actually be running on cloud-controlled devices. That's why they call the edge. It's a cloud-controlled device, but it's working outside the cloud data center. It's working at your location, at your physical location. So at the architecture they're having there, they show this solution here called the Azure Stack, which is an appliance, you know, like a server, 2-use, 3-use, whatever you want. Microsoft has a car that where they have this mobile data center based on Azure Stack as well. They use it on emergency responses after, you know, natural disaster and these things. Bottom line is there is a device in there that's running Azure software called Azure Stack, and the machine learning model you come to create, you containerize it, and you deploy to an environment where it can run. So in this case here, in this architecture, they are putting to run on, like I said, on Azure Stack, and on a Kubernetes environment, running pods with our containers inside these pods. And there will be users, doing whatever. It doesn't have to be a person here. It can be, like I said, cameras and these things, making calls through web APIs into these services in here. The important thing here to keep in mind is the model that was created in here got deployed, and its process is analyzing the incoming data at the edge, outside Azure, outside the cloud data center, which means that the response time here will be way faster. So this doesn't apply much to data people like us, because this is all about virtualization and orchestration and goes to the edge. But the bottom line is, nowadays we do have some Azure, some SQL Server services that are supporting this. They're coming out, they're kind of new out there, like a SQL Server Edge that can run on IoT devices in the edge, and they have interfaces. You can support machine learning also in the edge when you deploy, again, to Azure IoT devices. Arc is not really lined up with this concept here yet. Can be used because Arc is fully designed around Kubernetes, so it can be used in a sense, but not really specialized to this kind of cases or scenarios yet. And these services here in the machine learning, they talk to the cloud to report everything they do, but most important, they run the model in the cloud. And I have included here in the slide deck, when you download it later from the event website, I have here the link, so you can go and dive deep into this architecture there. Another architecture, and this, remember this first one here, let me go back one. This first one here is deploying your particular model. Remember, if you have a case that it's very specific to your business and you need it to be applied to your, for plantation, or where your business is running, monitoring your offices and all of that, the floor factory, whatever it is. This is what you want to, more likely this is what you're going to do, right? Because you need to deploy your models there, like that salmon farm, that's similar to what they have in there. Now, in some other cases, when the data can make its way to the cloud and can be processed in the cloud, you can do that one and have your model deployed to similar structure in the cloud, or you can leverage cognitive service, like I mentioned. If I go back here to the portal just quick, I deployed this one here, right? The machine learning studio to develop the model, or I can come in here and work with the cognitive service. So when I go into the cognitive service, if I go here, I think, and go to resource, there we go. When I go in here, so you see, these are the main services, the main subjects of the services that they're made available to me. And what I need now from this point on is creating the applications that will leverage these guys, right? Like I have my keys and endpoints in here. So I can copy my secret key here, put in my code, or put in the key vault, so my code can collect from the key vault. And within my code, I will be making API calls to this REST API endpoint. So if we go back here to the overview, let me see. Come on, go back. Where is it? API account, endpoints. And there we go. So let's say I want to do computer vision for analyzing images. So when I get in here, see, I got redirected to docs.microsoft.com, where I can get quick start codes where I will see actually code on how to make calls to that endpoint in there. And these are the snippets that your developers will be working with. Those keys I just showed you, they would go into code like this, and you're going to create your applications. Your applications can be Azure Functions, it can be your own REST API endpoints and things like that. So you're going to actually, it's a coding thing. So you're going to create these codes and deploying there. In this architecture, what they're doing here is like they're getting documents in. If you want to research this later, there is a sample case, a very interesting one they have done with the JFK case, the investigation of who killed JFK. So they got all the documents that are available. They're publicly available. And they did this. They got the documents into Azure and starting applying a bunch of machine learning from cognitive services, right? From a bunch of machine learning algorithms, and they trained on that knowledge base, and they start, digging up interesting facts from that. So in this architecture referencing here, they're mentioning the key phrase extraction, the language detection, and translation when needed, right, for the documents that are coming in. So let's say you're a law firm and you need to catalog your law documents and the cases and everything that happens around those cases, and start connecting them based on key phrase extraction, for instance. That's how you would go for this particular kind of cases, because like I said, they are somewhat industry standards. You would get way faster results going this way and embedding Microsoft Cognitive Service into your applications to deal with your particular data set, your particular code. And the last one I have in here for us is the one when it gets really close to my universe, right? As a data engineer, data platform guy, I deal a lot with Azure Synapse and Azure SQL Database, Power BI and Analysis Service, and all those things around that. So this is a very simple one, and this particular architecture is not really leveraging machine learning anywhere in the architecture, like the way they dispose in there. But I want to pinpoint to you where you can have either one, right? Where you can have either the machine learning model you developed yourself, or where you could call cognitive services. And by the way, before I get deep into this one here, let me make sure I mention one thing. It's not a side note, but something I think I should have mentioned earlier. One of the most important skills for a cloud professional, regardless of your specialization, like my one is data platform, some people do IT, some people do visualization, and some people do a bunch of other things, right? Regardless of what is your specialization, there is one skill that's common and must be mastered by all of them, which is budgeting. How much things will cost, right? Your cloud project is very dependent on how good you are on predicting how much it will cost. On regular deployments, people in the companies, they invest like $2, $3, $4 million in a data center, and they're gonna keep the data center working, but they're gonna reinvest in the data center in 5 or 6 years. They're gonna get that big bill in 5 or 6 years. When they go to the cloud, they get a bill every month. And if budget is not well done, that bill start going up and people stop considering cloud solutions, right? So you have to be able to predict bill. That's a very important skill. That's a given there. Just make sure you're on the same page. With that in mind, you have to understand that when you do machine learning, when you go into Machine Learning Studio, right, this guy here, and you develop your thinking here, developing it in terms of cloud expenses, it's really cost effective. It's really inexpensive, right? The amount of money you're paying here is just the cluster of computing you have. It's like paying for a virtual machine or a collection of virtual machines, depending on how big your features, your input data for training is. And you pay as you go. Like if you're not running your model, you're just parameterizing your pipeline, you can pause your computer. You're not paying for that. So this one here to run this thing is very, it has an expense on it. It has a price tag, but it's kind of inexpensive. And if I go back a couple slides in here, when I get that model created and I deploy it in production, what I'm actually paying here is the Kubernetes service, because I have already developed my model over here. If I was using this Kubernetes service here or deploying my model on a web app in the cloud, I would be paying for the web app support in the cloud, because the model is mine. I'm not paying for the model, right? I developed the model myself. So using this approach of using Machine Learning Studio, in terms of cloud expenditures, it tends to be less expensive. But the time to market is longer because you have to develop your model yourself. So that means you have a lot of consulting bills coming in, and you have specialized people coming in, your data scientists, all of these guys. You have to pay for the time as they develop your model. So the big bill here is usually behind the development of the model than actually running the model. When you go this model here is the other way around. Microsoft has already paid for all the guys to, and keep paying for the guys to create the models and keep training the models and make them smart enough to work with your data. But when you use these models, when you use cognitive service, you pay as you use these models. So the bill here in the cloud tends to be higher, but your time to market is shortened, and you don't have that many specialists on the weeds of machine learning working for your company. So you have to compare these two. When you get here to this last one, and again, keep track of my time, I'm like a minute now to wrap this up. When you get here into the data platform, you can use either one, right? Like when you go into Synapse, for instance, you can get your model into Synapse, and you have your Synapse functions, a particular function to call your model to process every row of a table, for instance, to try to predict the classification or regression, whatever it is, to that particular row, right? So you can get machine learning, your model running here for you. You can also get your model running on Power BI, for instance, right? Because Power BI has these extensions for R and Python. So we can load your libraries and your models into the Power BI environment to apply your models to the data that's available in Power BI, and have the visuals rendering whatever your model came up with. So you can have it there. Databricks, of course, it's well known for supporting models you come to create, so you can have them over here. When it gets into Data Lake, there is no compute in Data Lake. But when you do Azure Data Factory with the Data Lake, Data Factory can apply computing either by leveraging Sparks or other computing services like functions, Azure Functions, and then you can do either one. You call your own models in there to run. They're running from a container, for instance, in the cloud, or you can call cognitive services. So it's full of opportunities for you to deploy whatever you have come to create in your machine learning studio, or in the or reusing from the cognitive services. So you can have machine learning embedded in the factory. You can have machine learning embedded in the Databricks within Synapse, which is a very, very interesting feature, because you can have the machine learning deployed locally to the data storage. So we can do ELT if you want to classify it that way, which is a great, I've been using this a lot in some of my projects. So it's very interesting too on the new generation of Azure Synapse, and it's also in Azure SQL services, when you can do embedded Python, right? When actually Azure VMs, right? When you can embed Python in the VMs. So there is an opportunity out there too. So that's pretty much about it. Some closing slides in here where you can go to learn more. Some links here for you, and all of these links, they have hands-on, so you can, on your own time, it would take me a lot of time here to get to run all of them. But in your own time, you can go ahead and download these samples and have them working for you. You can do it in a couple hours. Very, very good resources there. Azure Microsoft Learn website has a bunch of snippet exercises that will take you anywhere from 30 minutes to 2 hours to run the collection of exercises. They're very simple. All of them are almost pretty much inexpensive. So we can take a look on that one, and you can use one of those Azure free accounts to run those too. And yeah, a couple more resources here from the GitHub repository from Ignite. With that in mind, one last time, let me hear from you if you got any questions. If not, I think I'm going to wrap up in here and give the microphone back. Thank you very much for attending the session. I hope you have learned something new, and I have given you a lot of entry points to start investigating where you can embed AI in your data platform solutions. All right. So good luck, and I see you around. All right. Great. Thank you. Thank you. Thank you all, guys. I have 3 screens here. This one is kind of